In this video, we're going to work through the classwork exercise 1 and exercise 2 of lesson 10. And we are going to solve all of the problems in this lesson by changing everything to scientific notation, or at least writing it with a power of 10 and solving the problems like that, with our final answer in most cases being in scientific notation. Number 1, we're going to do in standard and scientific notation for the final answer. The rest will be just scientific notation. So this first question, the speed of light is right here. And the first thing we're going to do is we're going to change that number to scientific notation before we do anything else. So 3 times 10, and then I'm going to count 3, 6, 7, 8. 3 times 10 to the 8. So the speed of light is 3 times 10 to the 8 meters per second. The sun is approximately 1.5 times 10 to the 11 meters from Earth. How many seconds does it take for sunlight to reach the Earth? So I can set this up as a proportion to see what I'm going to need to do. So this is meters, and I need to find the seconds that go right here. So how am I going to solve this problem to find this missing piece? I'm going to divide 1.5 times 10 to the 11th by 3 times 10 to the 8th. So 1.5 times 10 to the 11th divided by 3 times 10 to the 8th. And as we've talked about before, when we're dividing, the powers do not need to be the same. So I'm going to divide 1.5 by 3, and that's going to give me 0.5. And then I'm going to take 10 to the 11th divided by 10 to the 8th, which means I subtract 11 minus 8 to get 10 to the 3. Now I need to look at this. Is this proper scientific notation? No. I need to move the decimal one place to the right. 5 times 10. And when I move my decimal to the right, that reduces this exponent. So it's going to be times 10 to the 2. And this would be a label of seconds. And for this first problem, we're also going to write that in standard notation. 5 times 10 to the 2, I would need 2 zeros. It would be 500 seconds. So it takes 500 seconds for sunlight to get to the Earth. Okay, exercise 2. The mass of the moon is about 7.3 times 10 to the 22. And it takes this many moons to equal the mass of the sun. So again, I'm going to write this number in scientific notation, 2.6 times 10, 3, 6, 7 places. And then I'm going to figure out what I need to do to solve this problem. It would take this many moons to equal the sun. So what is the mass of the sun? So it takes this many of this to equal the sun. How would I find the total mass of the sun? I would need to multiply. So I'm going to take these two numbers, 7.3 times 10 to the 22 times 2.6 times 10 to the 7th. Again, I know that I can multiply the two decimal parts. And when I multiply that, I get 18.98 times 10. Now, 10 to the 22nd times 10 to the 7th. When we multiply our bases, we add exponents. So 22 plus 7 is 29. Now again, I have to change this to proper scientific notation. When I move to the left, 1.898 times 10, that increases this exponent by 1, 10 to the 30th. And we're looking for the mass of the sun, which is measured in kilograms.